Hi, today I will explain about convolution for one-dimensional signal, discrete time signal. Now, before that, we want to get used with the notation first. So, xn is our input signal. We feed the input to our system and we get an output called yn. And the system itself have impulse response hn. Impulse response is how the system responds by giving them an impulse signal. Now, before that, we have to remember that convolution can only be done when the system are time invariant and linear. Time invariant meaning if there is a time shifting for the input signal, then the output will have the time shifting at the same amount of time shift. And linear means that if two input signals are added together, then the output is added together also. And if a signal is multiplied by a number here, a constant number, then the output is multiplied by the same number. If a system is linear and time invariant, we often call it a LTI system. And with this system, this type of system, we can do convolution, which means we can count, we can know the output of the system when we know the input and how is the impulse response of the system. So the system is basically characterized by its impulse response. Convolution have a commutative property, meaning we can change x to h and h to x. Now we will see an example. Here we have an impulse response of hn and input signal xn. And now we want to know how is the output of the system. And because this is an LTI system, so we can just use the equation above. Now we see that in the equation, we need to do summation from k minus infinite to infinite. And we see here that our input system has only a non-zero value at n equal to 0 and n equal to 1. So here we put our xk. If you need an xk here, is basically we can change our xn into k, something like that. So xk use the k notation here and xn use the n notation here. So now all others are 0 except these two. So we can put here x, okay, x0 times x0. So the k is 0 here, and then hn minus 0. So hn plus x1, hn minus 1, hn minus 1. And for all the others, k is 0 because that is what our input signals are. So now we know that x0 is 0.5, hn is here given by the blue figure here, and then x1 is 2 and hn minus 1. So we need now the the impulse response that is shifted by 1. So because it's shifted, oh, yeah. It's shifted by 1. So we have here h and minus 1, and because it's shifted, so here it starts with 1, 2, 3, 4, 5, 0, minus 1. Yeah, something like this. Then, as we see here, the hn is time x0, so we need to times this by 0.5, which brings us to 2 times 0.5 is 1. And then here, we times it with 2. x1 is 2. So 2 times 2 is 4. Now we just need to add this two figure. What we have here, maybe I do it in green. So we do it point by point. For example, if n is minus 2, is 0 plus 0. If n is minus 1, 0 plus 0. If n is 0, then this is 1. If n is 1, then is 1 plus 4. Something like this. And then if it is 2, 1 plus 4. If n is 3, 0 plus 4. And then 4, 0 plus 0, 5, 0 plus. Yeah, we will have all 0 here. Yeah, so that's it. This is the output signal from a system that have impulse response as follow and given a input signal as follow. Hope that this video will help you in understanding convolution. Thank you.